We're gonna let my dad get out of his chemical gear there, and then he's gonna talk a little bit more about water chemistry and why pH is important. I'll talk a little bit first about the two main reasons people don't really understand why pH is important. So the first one is sanitation and safety. The second is swimmer comfort. So when you hear people talking about their eyes burning or being irritated, usually chlorine takes the blame for that, but it's actually pH. If your pH is too high or too low, that causes eye irritation. The second thing is pH is arguably more important than your sanitizer, especially to a lot of industry experts, because it actually directly correlates to how effective your sanitizer is. So if your pH is out of line, your sanitizer isn't keeping your pool safe.
What's available on the market right now to control pH, Dad?
Muriatic acid.
And
It's a standard treatment.
It's a standard treatment, and all homeowners use it?
Virtually all homeowners use it, or they use nothing. And then they run the risk of having sanitizer that's not doing the job. They end up putting more sanitizer in the water because the level isn't high enough, and they poison their water.
Gotcha. Okay. And tell me a little bit about pH and the science and how it works.
Well, pH is a range. It goes from 0 to 14. The scientific neutral is 7. What we want to do with pH, though, in a swimming pool is keep it somewhere between 7.4 to 7.7, because the human eye is typically right around, averages a little over 7.3 pH. So anything below 7.3, the human eye sees as acidic, and it starts to react to it with a burning sensation. If you get above 8, then it's too basic, and you end up with a burning sensation again. So the target is 7.4 to 7.7, because that gives us the most effective sanitizer, and it gives us the happiest condition for our eyes in the water.
And why is CO2 better?
CO2 is better because it stabilizes pH. Acid, as you pour it in, it simply is a bell curve kind of reaction. It goes in, it changes the pH, it's offset by the total alkalinity in the water, it's buffered out, and the pH starts to climb again. So you're constantly dealing with this up, down, up, down, up, down. Every 2 days, in some cases, you have to put acid in your water to bring the pH down. With CO2, that's not the case. It has a remarkable stabilizing ability, so that once you've got the right amount of CO2 in the water, the pH will stay at a certain range almost indefinitely.